In this video, we want to look at finding the area between two curves. And we're going to do this by using integration. Now, just to kind of refresh our memory with our integration, if we have the integral from 0 to 3 of 3x minus x squared, what we are looking for is we are finding the area underneath the curve. And the way we initially looked at this was we thought about finding the area of all these rectangles, and then we had n number of rectangles, and we found the limit and so forth. So just to kind of refresh your memory on how we did that, we're with these rectangles. Now I want to bring that back up because this idea of the rectangles will become important for what we're going to look at today. Now, we have talked a lot about finding the area under the curve by evaluating this definite integral and by finding the antiderivative and plugging the limits in from the fundamental theorem of calculus. With what we're going to be looking at here over the next couple weeks, we're going to just be doing some applications with the integral. So the main part of it is just setting it up. So once we write the integral, what we are going to do is we will just go to our calculator, go to our math, go down to our function integrator, and we will just type it into our calculator and get our answer. So the area underneath the curve here is 4.5. Okay. Now, what we are looking at today is not just find the area underneath one function and the area between that function and the x-axis. We're trying to find the area between two graphs. So consider this. I have two graphs here, 4 plus x minus x squared and 1 minus x. And what I want to do is find this area between these two curves. So let's talk about how we can do it. We'll come back to this one in a second, but let's just talk about in general how we would do this. So imagine we want to find the area between f and g, kind of the pink area here. Now, we know from our integrals, if I found the integral from a to b of f of x dx, that is going to be this whole area all the way down here between f and the x-axis. So this area here is my area. If I found the integral from a to b of g of x, that is going to be this area underneath g in the x-axis. So you can see if I want to find the area in pink up here, really all I need to do is take my f integral and subtract my g integral. And from our properties of integrals, we know we could combine this into a single integral, the integral from a to b f of x minus g of x dx. So that's what we want to do, is we want to find our area. So the important thing here is, though, you have to make sure that as you look at these, this f of x, the first one, has to be the one on the top. So in this graph, that is my f of x. The second one, the g of x, has to be the one on the bottom. You make sure you have to get those in the right order or it messes it up. So let's go back to our example here. The area between 4 plus x minus x squared and 1 minus x. Now you can see here, we want to think about this rectangle between these two. And that's important because as all the rectangles we've looked at have been going vertical up or down. They won't always stay that way. Now the other thing we got to do is we got to figure out what are we going to integrate from. Where are these 2 points where we integrate from? So if I go back to the previous picture, you can see that this is right at -1, and they intersect over here at 3. So my integral is going to be the integral from -1 to 3, and my f of x is the top one, so that's 4 plus x minus x squared minus 1 minus x parentheses around all that, and dx. Now, I want to show you kind of two different ways you could do this on the calculator, okay? The first way would just be to type it in. Just type in this whole integral just as you see it with all the parentheses. So if we do that, we go to math, integral from -1, let's try this again. Math function integrator, -1 to 3. And then we have parenthesis 4 plus x minus x squared, parenthesis minus, parenthesis 1 minus x, parenthesis dx, and you get your answer, 10.66. Now we can convert that into a fraction. If we want to write a fraction, 32/3. Now let me show you a different way to kind of think about this. Now, if we were going to do this, and this was a problem we were looking at for the first time and we didn't have the graphs, the first thing we'd want to do is graph these two functions. So let's graph both of these functions. And we see our graph here, and we can kind of find where our area is that we're looking for, this shaded area in here. And if we had to determine what our x's were, where they intersect, we could do that to get our x's. But let me show you a different way we could do this. So as I go to use my calculator here at my function integrator, I'm going to save myself some typing things in. I'm going to say -1 to 3, but now I have these typed in. So I can go to vars, y vars, function y1, minus vars, y vars, function y2, and then dx. And I don't need to type the full functions in. I can just say y1 minus y2, and I can get my answer that way. That will become much more useful as we go on and do these. That can make your life a little bit easier if we do that. If you don't have to, you can always just type it in straight out. But for some of you that makes sense, that can make your life a little bit easier. Okay. Let's look at another one. Sine of x to y equals x squared plus 2. First thing we need to do is we need to graph these. So let's go back to our calculator. Make sure we're in radians. Anything we graph, we want to be in radians. So we have sine of x and x squared plus 2. We graph that, and we get there. And we are integrating that from 0 to 3. So by looking at the graph, what we have to decide is from 0 to 3, which function is on the top, which function is on the bottom. And obviously the x squared plus 2 is on the top. So when we go to write our integral, we have the integral from 0 to 3, x plus 2 squared minus sine of x dx. Now, if you want to do this on the calculator again by using the y1, y2, you have to be careful what your y1 and y2 is. Here my y2 is x squared plus 2. So if I do my function integrator, I'm 0 to 3. And in this case, y vars, my first function or my top function is actually y2 because of the order I typed them in. And if I do that, I get 13.01 is my area between those. So when you do these, one of the first things you're going to have to do is graph them on your calculator. You're going to have to see what the graph looks like and then determine what your graph is. Let's try another one. We have e to the x minus x squared plus 3. So let's go here again. We have e to the x. And we have negative x squared plus 3. So we graph those. And we're trying to find this area between them. Now, you'll notice sometimes, as in this, sine of x, x squared plus 2, they give us this interval from 0 to 3 because there wasn't an enclosed area between them. Sometimes when they give us something like this, there is an enclosed area. You can see that enclosed area there between them. That is our area we're trying to find. So we're trying to find this area right in there. Okay. So the first thing we need to do is we need to find where they intersect. Okay. And I'm once again show you two ways to do this. One's a little bit kind of tricky on the calculator. One, you have to kind of write something down. So the first thing I'm going to do is I'm going to go to intersect, and I'm going to find this spot over here where they intersect. Negative 1.677. So I'm going to come back here, and I'm going to write that down is negative 1.677. And that is that first intersection point. Now, here's a trick in kind of helping us. Instead of writing that down, if I go back to my calculator here, and I just type x, that negative 1.677 to a lot more decimal places in there. So here's a little trick I'm going to do. I'm going to say store that into A. Now that number is stored in A. Now I can go back to the graph and I can find my other intersection point, which should be over here. And if I wanted to, I could write that down, 0.834. Or I could come back here, say x, I get that number, and I can store that into B. Now, if we look at my graph, you can see that the x squared is the top one, the e to the x is the bottom one. So if I'm going to write down my integral, and one of the things that you're asked to do as you do these problems is always write down what the integral is. So 1.677 to negative or to positive 0.83, let's say 4. My negative x squared plus 3 is first, minus e to the x dx. Now, I could just type that exact thing into my calculator, but let's kind of show the little kind of trick that I can use to make this go a little bit quicker and a little bit easier. So I know my x squared is my y2. So I'm going to go to Math, Function Integrator, and I've now saved that negative 1.67 is A, and I've saved that 0.83 is my B, so I don't need to type them in. I can go to vars and go to yvars 2, which is the x squared is first, yvars function y1, get my x, and get my n. So I get that. Now, if you don't like that and you want to actually type everything out, I could go negative 1.677. I could go 0.8345. I could do parenthesis negative x squared plus 3 minus e to the x, and actually type this whole thing in and get enter, and I get, oops, messed something up. What did I hit wrong? Oh, I needed a minus, not there. And you get that, which is almost the exact same answer. If you remember, it's just off a little bit because of some rounding, but pretty close. Close enough for us as we go to 3.652. Now, where it can get a little trickier is if you have something like this. So let's imagine for a second we want to find this area between the two curves. So what we would have to do is, and let's say we're going from 0 to b. You can notice right here at point C that it switches. Over here, F is on the bottom, G is on the top. After C, it switches. So to do this, we have to find point C on our calculator or whatever. And so I'd have to do the integral from 0 to C of G minus F, and that's going to give me the first half, plus the integral from C to B of F minus G, and then that's going to give me the second half. So if you have these problems where they can be split up, you may have to break them into multiple integrals. So let's look at an example. Let's say we have this area. We have the area underneath the square root of x between the line y equals x minus 2 and the x-axis. So this area in here, and I'm showing the rectangles to help us kind of visualize what's going to happen. And you notice, if I draw my rectangles, I can kind of see that these last couple rectangles over here are different. They don't go to the x-axis. So what I need to do is I need to split this up into multiple integrals. Now, here, this is 2, and this is 4. So what I need to do is I need to split this up as one integral from 0 to 2, and that first integral is right here. That is just the square root of x dx. However, the second integral here is between the two functions. So this integral from 2 to 4 is going to be the square root of x minus the line x minus 2, like that. And if you put those into the calculator, you get 3.33. If you want to check, this first part should be 1.8856, and the second part is 1.4477. So as I said, the goal here now is not so much just evaluating the integral, but it is writing the integral. So these integrals we can evaluate on the calculator. We can figure out what the integral has to be. We may have to figure out our limits. The limits may be given to us, but we do need to figure out which one's on top. Which one is the first and which one is the second as we try to calculate what the area between these two curves are. Now, one thing I want to talk about to kind of lead us into our next video is if we look at something like this, and let's say we are looking at this area right here. So you see, if we look at this area, we have a whole bunch of different things here. Over here, we have an integral between those two curves. Over here, we have an integral here. Over here, we have an integral here. So we need to split this up into multiple parts. So in the next video, we want to look at a way we can do this that's actually much easier than splitting it up into multiple parts. All right, we are ready for the homework. You can do the homework over 6.1. And that homework then, once you are done, you can take a picture and submit that on Google Classroom.